A pleasant good day, students. Today we'll be continuing with circle theorems, and in today's class we'll be reviewing all the theorems that we did with respect to circle geometry. So I'll just do a quick recap with respect to all the theorems, all the rules, and then we'll be answering a question pertaining to this. Now in circle geometry, we have a listing of theorems that we use to answer circle geometry questions. The first theorem that you need to know with respect to circle geometry is if it is that we have a circle, and inside the circle, if a line is drawn passing through the center of the circle from either points on your circumference, this line is called the diameter. If it is that we have a line touching one point on a circle, this is called a tangent. Right, so I just illustrate this here, just put a small note. This here is called a tangent. This line here is a diameter. So we have a diameter, we have a tangent. Also, we have a line that is called a chord. A chord is a line that connects 2 points on your circumference. So this line here, we also call that a chord. So these are terms that we will be using later on. Now the first theorem, having known these different terms, the first theorem would be that of a radius and a tangent. So a radius is just a half of a diameter. If it is that we draw a line from the center of the circle to any point on your circumference, that is called a radius. And where the radius meets a tangent, right? So the radius and a tangent meets. Wherever a radius and a tangent meets, the angle between the radius and the tangent is 90 degrees. So this is theorem 1. The angle formed between a radius and a tangent is equal to 90 degrees. Moving on to theorem 2. If it is that we have a circle, and inside the circle, we have a line connecting 2 points on a circumference passing through the center of the circle. This is called the diameter. And the diameter now, on either points on the diameter, a line is drawn from either points touching one common point on the circumference. Right, so we have a shape like this, a triangle like this. Wherever these two lines meet, the angle formed at this point on the circumference is 90 degrees. And the rule for this second theorem states that the angle formed in a semicircle is 90 degrees. So that is theorem 2. Moving on to theorem 3. If it is that we have a circle again, and inside the circle, if it is that we have lines meeting at points on your circumference and forms a quadrilateral, we call that a cyclic quadrilateral. As quadrilateral is a four-sided figure. And if it is that we have a four-sided figure inside of a circle, the opposite angles adds up to 180 degrees. Right? So the rule for this is that opposite angles in a cyclic quadrilateral are supplementary. Or that means that they add up to 180 degrees. So the opposite angles are like this. If here is 80 degrees, then this angle across here will be 100. Because of the fact that in a cyclic quadrilateral, which is a four-sided figure inside of a circle, the opposite angle adds up to 180 degrees. So this is theorem 3. Moving on to theorem 4. If it is that we have a circle, and inside the circle, we have a line from the center of the circle touching a point on the circumference. That is a radius. You have a next line from the center of the circle touching a point on the circumference, another radius. So we have two radii. If it is that where each of your radius touches your circumference, a line is drawn to a mutual point on top. So it meets on top at a mutual point. We have a shape like this. And this theorem states that the angle at the center of the circle is twice the angle at the circumference. What this simply means, if it is that the angle on the circumference is 50 degrees, then the angle at the center of the circle would be 100, because of the fact that the angle at the center is twice the angle at the circumference. Vice versa, if it is that they give us the angle at the center, let's say for instance they give us the angle at the center to be 120, we can safely find out the angle on the circumference by dividing it by 2, using the rule that the angle at the center is twice the angle at the circumference of the circle. So 120 divided by 2, what we get? We get 60 degrees. So that is theorem 4. Moving on to theorem 5. This theorem states that, for theorem 5, this theorem states that they call it the alternate segment theorem. If it is that we have a circle, and inside the circle, if a line is drawn touching a point on the outside of the circle, that is called a tangent. And inside the circle, if a triangle is drawn at that particular point where the tangent touches the circle, if a triangle is drawn on top of that point, we have a diagram like this. And the rule for this states that the angle formed with either sides of your triangle is equivalent to the interior opposite angle of your triangle. So if this angle here is 65 degrees, the interior opposite angle of your triangle will be this angle inside here, right? 65. Right? Think of it as this. Each of your angle, so the angle formed on the outside of the triangle is equal to the angle formed on the inside of the triangle. So think of it as this. Diagonally, these two angles are equivalent. So the rule for this states that the angle formed on the outside of the triangle, or the angle formed with each of the side of the triangle, is equal to the interior opposite angle. If this angle on the outside here is 70, diagonally, if it is that you draw a line diagonally, then that 70 degrees will be equal to the interior opposite angle. So this angle on the inside here will also be 70 degrees. Right? So this is our theorem as well. We call that theorem 5. Theorem 6 now. If it is that we have a circle, and on the circle, inside the circle, we have a chord. Right? So we indicated what is a chord. A chord is a line that connects 2 points on the circumference. And on top of this chord, a line is drawn to touch a point on the circumference. On top here, a line is drawn here. And if it is that we connect these 2 points with the baseline, with the base point, we have a diagram like this. So if it is that you all get a diagram like this in the exam, what this simply means, if it is that this angle here is 70 degrees, then this angle here is also 70 degrees. And the theorem for this states that the angles formed in the same segment are equal. So that is another theorem. Angles formed in the same segment on top of a chord are said to be equal. Right? So we have 6 theorems there. The last theorem, the last important theorem that I want to introduce you all to, theorem 7. A circle drawn and a line drawn from the center of the circle to a point on your circumference. This is called a radius. Another line drawn will also be a radius. So we have 2 radii. If a triangle is formed with the 2 radii, knowing that a radius Let's say the radius is 5 cm. So if one of your radius is 5 cm, then obviously the next line, which will be a radius, also will be 5 cm. And what this shows us, that the two sides of the triangle has equal length. So the term given to this is called an isosceles triangle. An isosceles triangle is a triangle that has two equal sides. So if it is a two radii, it forms a triangle. That triangle will be called an isosceles triangle. And an isosceles triangle also has two equal angles made with each of those sides. So if this side is 50 degrees, then this side, the angle formed with this side would also be 50 degrees. And 50 and 50 is 100. Bringing us to the next theorem. Internal angles of any triangle adds up to 180 degrees. So I say it again, internal angles of any triangle adds up to 180 degrees. So 50 and 50 being the sum gives us 100. 100 taken away from 180, you get 80 degrees. So these are listing of the most important theorems we use in circle geometry. This video is just an introduction to these theorems. So the next video that I'll be posting will be questions based on these theorems that CXC had in the previous years. Right, so I hope that you all use this video. I hope that it serves the purpose of education, where it is that you utilize these videos so that you all can learn from them.